Just a second, everyone. I think there is a little issue with the internet. Zainab and Shamin, am I audible?
Yes.
All right. Bismillah ar-Rahman ar-Rahim. I hope you all are there and I am perfectly audible. Today we will start with a new chapter. As you all know, we've completed the most important chapter in my opinion, that's called chemical reaction. In chemical reaction, we studied everything, you know, as far as, rate of reaction are concerned, redox reactions are concerned, and reversible reaction, rate, redox, reversible. So we studied the entire thing in all 3 topics. We did like 2 worksheets in the class, and there was a worksheet which I sent on Thursday. Most of you have attempted, but I didn't get the 100%, answer sheets back on Saturday. Some people, I think I'm audible. Yes.
Yes, sir, you're audible.
Yes, sir,
Okay.
you are.
So today we need to start with a new chapter that is about chemical energetics. In my opinion, it is very easy chapter. You would probably fall in love with this chapter given the amount of data. अभी शुरू करेंगे, अभी खत्म हो जाएगा इंशाल्लाह. And it is very easy. And of course, इसमें सबसे जो predicted question है, जो confirm बातें आने ही आने, वो इस chapter में से है. There are only 2 topics in this chapter. वो 2 topic ऐसे हैं कि it will, वो take not more than 10 or 15 minutes, inshallah. So I hope you all are ready, right? So chemical energetics, I want everyone to listen, pay attention, and note if anything you want to note on your copy. Otherwise, you will get these PDF notes. I want you to pay full attention, connected, ask any question. I would love, answering your questions. Bismillah ar-Rahman ar-Rahim. The topic for today's class is chemical energetics. So chemical energetics. Energetics talks about the change in, when it's about energetics, that means that refers to the enthalpy, change in heat of any reaction, right? So chemical energetics, in chemical energetics, we are going to study the heat change whenever there's any reaction happens. And there are different type of reaction in our surroundings. For example, we have a gas called methane gas. You burn the methane gas. Whenever we burn something, that means we are reacting that particular substance with oxygen. So reaction with oxygen is known as combustion reaction. So when you react methane with O2, that means you're burning methane. Whenever you burn any certain compound, you will get oxide of that element. So in this molecule, we have carbon and hydrogen. So when you burn a molecule which have carbon and hydrogen, you will get carbon dioxide for carbon and you will get water for hydrogen, right? And we know every combustion reaction is releases heat or absorbs heat. Every combustion reaction releases heat. So this gives out heat. On the other end, you see we have, for example, you have ice, H2O solid, and we are melting it to become a liquid. So the process of when solid is being converted into liquid, or for example, this liquid is converted into gas, in both of these physical changes, we have to supply the energy to the solid so that it becomes liquid. Since we have to supply the energy, heat is taken in, right? So also here. So there are a variety of types of questions when it comes to change in energy. There are reactions in which, as a result of those reactions, heat is released to the surroundings. And when heat is released to the surroundings, for example, imagine we are standing in a kitchen and we are burning, that particular gas. You see, you cannot stand in the kitchen when there is no exhaust because the temperature of the kitchen would go like above 30, 40. Because of the combustion reaction, the temperature of the surrounding rises as the heat is released to the surrounding. And contrary to this, In an endothermic reaction, when the heat is absorbed, the temperature of the surrounding falls. For example, you pass by a canal road पे आप लोग travel करते हैं लाहौर में. Even in the summer, we feel cooling because of the fact that in canal there are water molecules and there is evaporation going on. Evaporation is when liquid changes to gas. So the liquid particle of water, they absorb the energy of the surrounding and the temperature of the surrounding falls and we feel cooling. So we have two, and that change in energy is called enthalpy. So the first thing that you need to know is enthalpy. It is represented by delta H, right? Delta represents change and H represents enthalpy. So the change in heat in a reaction. Change in heat in a reaction, in a chemical reaction, is called enthalpy of that reaction. Now, as we've just discussed, that change in heat, it might be positive or negative, depends on the type of reaction. So we have variety when it comes to delta H. Delta H may be positive, which means the reaction is endothermic. And if it is negative, we see exit. The reaction is called exothermic. In endothermic reaction, the sign for the delta H is positive, and in exothermic reaction, the value or the sign for the delta H has to be negative. Let's describe both of these reactions in terms of, releasing or absorption of heat. In an endothermic reaction, a type of reaction in which heat is absorbed from the surroundings. So from where the heat is absorbed, of course it is from the surroundings. So a type of chemical reaction in which heat is absorbed from the surroundings. So when the heat is absorbed from the surrounding, what happens to the surrounding temperature? When the surrounding temperature is absorbed, the temperature of the surrounding decreases, falls. And that's the reason we feel cooling. A type of reaction in which heat is absorbed from the surroundings and the temperature of the surrounding falls. And the temperature of the surroundings falls. Makes sense, everyone? So whenever the delta H is positive,
Yes, sir.
that refers to, excellent, that refers to an endothermic reaction. In an endothermic reaction, heat is absorbed from the surroundings. Since heat is absorbed from the surroundings, the temperature of the surrounding falls and we feel cooling. The example of endothermic reaction is, like, for example, for endothermic reaction, heat is absorbed, so you should say melting, yes, Anaya, and boiling. That's a
In
physical
past papers,
example.
there's a
Yes.
question that asks that what is the temperature of the reaction that takes place, like in the beaker. So wouldn't, if the heat is being released, absorbed, wouldn't the temperature of the beaker and the overall reaction increase? But usually they say that the temperature of the reaction in the beaker decreases in an endothermic reaction. So what's the science behind that?
Can you please repeat your statement?
So see, वो कहते हैं in the MCQs कि you know how in an endothermic reaction the heat is absorbed from the surroundings. So
Yes.
there's a question that comes that what happens to
Mhm.
the temperature of the beaker in which the reaction is taking place. So
Mhm.
usually the answer is that the temperature of the beaker and the reaction decreases.
Can you
But
please share
wouldn't
that question with me after the class?
मैं आपके साथ share कर दूंगी.
Okay. All right. So the example of endothermic reaction is melting. In melting, heat is absorbed by the solid particle to become liquid particle, and further the liquid particle absorb energy to get into gas, and the process is called boiling. But the more important example is, I want everyone to note this, bond breaking. Whenever we break the bond in any reaction, whenever we break the bond, energy is always used to break the bond. For instance, you're breaking a molecule of hydrogen. This is a molecule of hydrogen, so you're breaking that one particular bond to form the atoms. right? So atoms are always gaseous. So that process, in that particular process, heat is absorbed and the process is called endothermic. Endothermic reaction are those reactions in which heat is absorbed. Bond breaking is endothermic. If bond breaking is endothermic, then bond forming is exothermic. So please keep that in mind, everyone. There would be a confirmed question
Okay,
in terms of
sir.
bond making and breaking. Explain that why reaction is exo or endo. So bond forming is exo. For example, let's reverse this very reaction. Here we have the similar example, but this time we have two hydrogen atoms, gaseous atom, and we are making them react to form a molecule of hydrogen. So you see that in this very reaction, there is no breaking, only the formation is taking place. We have two gaseous atoms of hydrogen, both are reacting to form a bond. So only formation, since formation is happening, formation, and information energy is always given out. So bond formation is exo, breaking is endo. Now let's describe exothermic, a type of reaction in which heat is released, heat energy is released to the surroundings. So if the heat energy is released to the surroundings, the temperature of the surroundings increases, including the thermometer of the surrounding rises. Make sense, everyone? Please say
Yes,
yes.
sir. Yes, sir.
Good. For example, let's reverse the process. Endothermic process are those, melting and boiling. If melting is endothermic, what is reverse of melting, Zoya? The reverse of melting.
Freezing.
Freezing. Then freezing must be exo. What is reverse of boiling? It should be condensation, right? So, but as I said, bond making and breaking are more important. Now, these are the definition. I hope you all are clear with the idea that what is and chemical energetics. What are we going to study in this very chapter? The heat change. This chapter particularly talks about the heat change in every reaction. As I mentioned, that when it comes to heat change, there is a variety. Some reaction releases heat when they proceed, and on the other end, some reaction absorb heat from the surrounding. So those reaction which absorbs heat from the surroundings, their value for the delta H is always positive, no matter if it is +1, +10, +100, or +1000. If the value is in positive, the reaction must be an endothermic reaction. And if the delta H is negative, the reaction must be exothermic. In an endothermic reaction, heat is absorbed and bond breaking is endothermic. Keep that in mind, everyone. Exothermic reaction, heat is given out. So for exit, you should remember exothermic. Heat is exit, heat is released to the surroundings. So when heat is released, the temperature of the surrounding rises, and the bond formation is exothermic. Now, this is more important. I want everyone to draw these energy profile diagrams with me. So please write energy profile diagram. Energy profile. Right? Let's draw first for endothermic. गौर से देखना है सबने. First of all, we'll label the axis. X-axis is actually time, or you can say progress of reaction. Usually we take it in minutes. And y-axis, along y-axis, we have energy. Make sense, everyone? So first of all, you should be able to label the axis. No matter if the reaction is exo or endo, y-axis are always energy, and x-axis is always the time or the progress of reaction. Both are correct. Now, since this reaction is endothermic, the reactant must absorb energy to form the product. So if something absorbs energy, and after the absorption of energy, the products form must have greater energy than the reactants, since the products are being formed once the reaction have absorbed energy. So imagine, I want everyone to look on the screen. So this is the level of the energy of the reactants, right? They will cover the barrier of the activation energy and then they will, the peak gets lower, and at a particular point we will label this as reactant, but don't stretch the line. That line must not exceed this, ये वाली line, x-axis की line exceed नहीं करनी चाहिए. So that line which touches the y-axis always represents the reactants. अच्छा, एक और चीज का भी ख्याल रखना है. Most of the time I find people, ये वाली जो line है ये बिल्कुल straight आप लोग draw करते हैं, and then you straight, आप इस तरह बच्चे draw करते हैं, and then they get back. This is an incorrect way of, for the diagram, because here you can see that the line is, goes up without any deflection. So at this particular point, if you look at the x-axis, ऐसा लग रहा है कि within no second आप बिल्कुल आपका reaction ऊपर चला गया, but that is not possible practically. So reaction goes slowly. देखो reaction ऊपर जा रहा है, तो after this point reaction has touched the peak. So इतना time लगा है उसको to touch to the peak, whatever that peak is. So always try to draw a curved peak like this. It should not be like this. I hope you get the point, everyone. Yes? And curved peak going up and a curved peak going down. If it is endothermic, then the product must have high energy. So if this is reactant, these are our products. Make sense, everyone? So this is the energy of the reactants. This is for just your understanding, not part of the labeling. This is the energy of the reactants, ER. And this is the energy of the product. So which have more energy, the reactants or the products? Clearly you can see the products have more energy because energy is increasing as you go up, right? So reactants are along y-axis and product away from y-axis. But in endothermic reaction, product have more energy. So we still have to label it. Listen, everyone. The difference of energy between the reactants and the product, the difference, the change in energy between the reactant and the product is known as enthalpy. And look, whenever you label the enthalpy, I never labeled the two arrows incorrect, or I never put the arrows toward the reactant. The direction of the arrow, an important point, please. The direction of the arrow always towards the product. Starts from the reactants. This is the level of energy of the reactants, and this is, but you always draw with the dots. That's how you label the delta H. In this case, product have more energy, so delta H has to be positive. Makes sense, everyone? But we also know that there's an idea called activation energy. I hope you all are familiar with activation energy. It is that minimum energy needed to start any reaction. Activation energy is always from the reactants to the peak. And again, the arrow direction has to be towards the peak. This is our EA, activation energy. Make sense, everyone? Please say yes. That is a complete diagram, labeled energy profile diagram for an endothermic reaction, concluding the axis, how to correctly draw the reactants, the level of the products, how to correctly label the delta H and the EA. Right? All right. Hold on, everyone. Imagine, ये सबको समझ आ गया?
Yes, sir.
Ayla and everyone?
Yes, sir.
Yes. Okay. Imagine I put a catalyst in the same reaction. I want you to draw on the same diagram, draw the effect of catalyst. Imagine, think for a second what catalyst is. We use a catalyst in the same reaction. This was the reaction in the absence of catalyst, Ryan. And we use the catalyst. Now draw on the same profile diagram the effect of the catalyst. So we have SN, Nile. This is the task I want everyone to complete. Dr. Zainab, Amna, Shabash.
Done.
Excellent. Amna done? So starting with Amna. Amna, what is the effect of catalyst? If we use the catalyst to this reaction, what effect would it cause?
The curve will be smaller for the activation energy, or choti bana denge to show that
But
it's
okay. Do you think it will cause any effect to the enthalpy?
no.
Okay, how would you describe the term catalyst, Amna?
Like the minimum energy needed to start a reaction.
All right, excellent. So catalyst is something that is used to speed up the reaction by lowering the activation energy. And activation energy is the minimum energy needed to start a reaction. We can lower the activation energy. We can decrease the activation energy by using the catalyst. So initially, this was the activation energy without catalyst. If I use catalyst, the activation energy is decreased, but the overall enthalpy remains unchanged. So let me write the effect of catalyst here. EA with catalyst. This is the EA without catalyst, right? So let's use the effect of catalyst. Catalyst only lowers the activation energy. Lowers what? EA, but cannot affect the delta H. ये सबको बात clear हो गई, सबके दिमाग में आ गई ये बात? That the catalyst only affects the EA, but it cannot alter the delta H. In fact, nothing can alter the delta H. It remains the same for every single reaction. All right? Makes sense? So when you use the catalyst, it lowers the activation energy, but no matter if the reaction is exothermic or endothermic. As Amna just mentioned, the definition of activation energy, it is the minimum energy needed. So when the minimum energy needed, Zainab, when the energy is needed, what type of reaction would it be? Exo or endo? When the energy is needed? Endo. So please note this, everyone. No matter if the reaction is exothermic or endothermic, EA, which is activation energy, is always endothermic. Okay, for more better understanding, I want you to draw the profile for exothermic reaction, and then we will connect this. This is for exothermic. So again, we have time here, and we have energy here. For exothermic reaction, heat is released, and when to get the product, since heat is released, the product form must have low energy than the reactants, right? So we have the reactants over here. You should draw for exothermic reactant have high energy. They cover that barrier of activation energy, curve down, and then they form the products. So can you spot the difference between the exo and endothermic reaction? Again, something that is close to y-axis has to be reactants. And these are the products. Bhai samajh aa rahi hai na sabko? Now, let's label the enthalpy again. The concept of enthalpy is the difference between the reactants and the products, right? So we have the products here, and that is for the reactant. And I told you the arrow is always towards the products. Here the product was drawn above, the arrow was towards the product. Here the products have low energy, so the direction of arrow must be toward the product. And that is the enthalpy. Since the product have low energy, enthalpy must be negative. Now, where to label the EA? I want everyone to label the EA in this reaction. The EA. Please, everyone. Done?
Yes, sir.
The activation energy always, please write, activation energy always starts from the reactants, right? From the reactants. So this time the reactants have this much energy. So from the reactant to the peak, and for activation energy, the direction of arrow must be from the reactant to the peak, and it should touch the peak. If you draw activation energy like this would be incorrect. Like this, it must touch the peak of the curve. Correct? Yes. Now, if you look at into the energy profile of both reactions, the energy profile, closely have a close look on the activation energy. In both profiles, the direction of activation energy, the arrow, is going up. So whenever arrow is going up, it is always endothermic. So activation energy is always positive, no matter if the overall reaction is exo or endo. But activation energy is more positive for endothermic. That's a difference that you can notice. I hope you get the logic. Amna and everyone, Ayla, Anaya,
Yes,
Zainab.
sir.
For
Yes, sir.
endothermic
Yes,
reaction,
yes.
could you see that major arrow, that the big line? And in exo, it is still positive, but it is less positive. So when the activation energy is that high, what does it tell us about the reaction? It is more easy to take place, or it's difficult to start that reaction? The reaction have more activation energy. What does this tell us about the start of the reaction?
It's more difficult.
It's difficult. That means exothermic reaction are more likely to take place. They're more feasible. They're more spontaneous because their activation energy is very low. जो गाड़ी जल्दी स्टार्ट हो जाएगी, भागेगी, that means that is very suitable. I mean, that is spontaneous. Very less energy is needed to start that car, whereas a trawler need that much energy. So endothermic reaction are difficult to start because they need more energy for the उनको start करने के लिए. That's called activation. Exothermic reaction में, I mean, very little energy needed, and they boom. Make sense? Please say yes.
Yes,
Excellent.
sir.
Yes.
All right. Even if you add catalyst to this very reaction, that will make no difference to the enthalpy, but will lower the activation energy. Enthalpy remains the same. So this red line represents the EA with catalyst, and this is the EA without catalyst. Right? भाई ये सबको क्लियर होना चाहिए. इंशाल्लाह जब आप लोग स्कूल जाएंगे in August, I want everyone to feel confident in chemistry class, in every single class. But as far as this particular subject is concerned, I want everyone to feel confident, conceptual, answer the question. Doesn't matter if you are, if you are a good, participative student or student. When I was in class, I still remember grade 9 में I was really shy. 10 में थोड़ा और अच्छा हो गया. 11 में मैंने कहा यार ये तो easy था, मैं डर रहा था. So it's always about the knowledge, about the confidence. Even if you're not sure about the answer, always try to tell whatever is in your head. That will give you confidence, and no answer is wrong answer. It's always something we are trying in a different way, and maybe sometime the teacher has a different approach. But I want everyone to participate in your physical classes, so as you participate in this online class, because it is easy to participate in physical classes. You're standing in actual classroom. So here we are making this class more productive, and I always believe that online classes is something more productive. I believe in physical class there are 30 or 50 people sitting in the same room. Some are backbenchers, some are standing in the middle of the room. Teacher, sometimes cannot give you the full attention. But here in online classes, my voice, teacher's voice directly coming into your, यहाँ पे सबके you're equally आप सब लोग front row में बैठे हुए. So as far as online classes are concerned, if you are mature and if you are actually serious about your studies, I feel we can make more out of these classes, inshallah. And I hope आपने feel किया होगा for the last 2 weeks or 3 weeks जब से भी आप लोगों ने join किया है, that we have done alhamdulillah some good amount of data as far as the chapter are concerned, or the understanding of the past papers, or when it comes to MCQ or theory. It's all about how serious we are with ourselves, not with anybody else, not with the teacher, not with the parents. How you people are serious with yourself. End of the day, inshallah, आप सबके grades आने हैं, and of course आपका result would be my result. So I want everyone to have to put maximum effort, and inshallah there is no point कि हम इस चीज को बेहतर ना करें. There is no point. Inshallah, you would see slowly and gradually you will become master in solving the past paper, whether it is ATP questions or MCQ questions or theory questions. So everybody clear with the profile diagrams? Please say yes. Right?
Yes, sir.
Yes, sir.
All right. So just one last question, and then we will continue from tomorrow. I mean, most of the time, there is a very frequent question, and you would see the question in my worksheet as well. For example, there's a question, this question, we get CO2 and H2O, and this is an exothermic reaction. Examiner wants you to predict the sign of enthalpy. Please, I want everyone to try. For the sign of enthalpy, that's the first mark, since the reaction is exothermic. Now, the major important question is for 2 marks, in terms of bond making and bond breaking. Describe to start में आना था ना. describe why this reaction is exothermic. Now listen everyone. Ready? So we are given with the chemical reaction. That reaction is exothermic, so the sign of enthalpy should be negative. सबने एक number ले लिया. Everyone got that 1 mark by correctly predicting the sign of enthalpy?
Yes, sir.
Correct? Okay. Now, examiner wants us to describe this very reaction in terms of bond making and breaking. This is a very common question, and you would see, inshallah, in the same question in your Cambridge exams. This is a 2-mark question. So we need to explain this question in terms of bond making and bond breaking, right? So we've just learned that bond making is as bond. What type of process bond making? Is it exothermic or endothermic? Bond making is
Exothermic.
excellent. So you would say the first sentence, you would tell the examiner that, look, Gore uncle, as bond making is exothermic and bond breaking is endothermic. Bond breaking is endothermic. The moment you write this very sentence, you'll get 1 mark. Bond making is exo, bond breaking is endo. Now, I want everyone to look into this very reaction. In this reaction, SN and everyone, we have this molecule called methane and the other molecule called oxygen. So whenever there's any reaction, we break the bonds of the reactants. We break the bonds between carbon and hydrogen, between oxygen and oxygen. We break the bonds and new bonds are formed. And that's why there's a chemical reaction. That's why that's how we got the products. If there is no bond breaking taking place initially, you won't get the product. So in every reaction, in every complete reaction, there is both breaking and forming. Breaking happens with the reactants and forming happens with the products. Make sense? Yes. So you break the bonds of the reactants and new bonds are formed on the product side. Whenever the overall enthalpy is negative, that means more energy is released when bonds are formed and less energy is absorbed. Correct? If in every single reaction, as I mentioned, both processes are taking place at the same time. You are breaking the bonds and the new bonds are being formed. Then why the reaction has become negative? Why sometimes it become positive? It is due to the fact that sometime more energy is released and less is absorbed, or sometime more is absorbed than released. So it depends on the nature of reaction. But the first sentence would be similar for every kind of reaction, no matter if the reaction is exo or endo. The first sentence, your answer, the first line of the answer must be same. As the bond making is exo and bond breaking is endo. Now, since this very reaction is exothermic, what would you say? In this reaction, इसमें क्या हुआ है? ज़्यादा release हुई है या absorb हुई है? What should I say in the second sentence? In this reaction, more heat is released or absorbed, since this is an exothermic reaction, Zainab?
Released.
Excellent. So we would say in this reaction, more heat is released in bond forming. ये आप लिखो ना लिखो, क्योंकि ऊपर हमने बता दिया ना, bond forming is exo. In bond formation, and less is absorbed, less heat is absorbed in bond breaking. So सबको समझ आ गई how to answer this easy question for 2 marks, and that would be a confirmed question, I'm telling you. Right? What if the reaction is endothermic? How would you explain that reaction in terms of bond making and breaking? I want you, Zoya, you to start. Imagine this reaction is endothermic. How would you answer this question for 2 marks? I want everyone to listen. Yes, Zoya.
The first part stays the same as bond
Excellent.
making
So,
is exothermic.
listen, everyone. So the first part, as Zoya mentioned, it would remain the same, no matter if the reaction is exo or endo. You should say, as bond making is exo and breaking is endo. What should be the second sentence, Zoya?
In this reaction, more heat is absorbed in bond.
Excellent.
breaking unless heat is released in bond formation.
Excellent. So you should reverse the second sentence. If the overall reaction is endo, you should say more heat is absorbed. And if overall reaction is exo, you should say more heat is released. That's it. Make sense, everyone? Okay, so Bismillah ar-Rahman ar-Rahim. Let's review the entire thing. We started with energetics. The first thing that you should know in energetic is enthalpy. It is the heat change in any reaction. How many types of enthalpies, Nile? How many types of enthalpies?
2.
The positive and negative. So whenever enthalpy is positive, the reaction is called endo. Enthalpy is negative, reaction is called exo. एक याद कर लो, दूसरा उसका reverse है. In endothermic reaction, heat is absorbed from the surroundings and the temperature of surrounding falls. And bond breaking is a perfect example of endothermic reaction. Bond breaking is endothermic. Bond forming is exo. सबसे important चीज आज हमने ये पढ़ा है, that is the energy profile diagram for both endo and exo. Activation energy is the energy needed to start a reaction. It is always positive, no matter if the reaction is endo or exo. It is more positive for endo. You can change the activation energy with the use of catalyst, but you cannot never change the enthalpy. So catalysts have no effect on the enthalpy of any reaction. Keep that direction of arrows in mind that I've just explained. Enthalpy is always toward the product, and activation is always toward the peak from the reactants. All right, and that's it. See you tomorrow, inshallah. We'll complete the entire chapter tomorrow along with the revision of this. Please join exactly at 7:15. Allah Hafiz.
Allah Hafiz.
Allah.